All right, so in the last chapter, we learned about what a matrix is and why we use it in linear algebra. In this section, what we're going to go ahead and do is explain some special forms of matrices. But before I do that, I do want to just explain a couple more vocab terms. So the first one's going to be a leading entry. And a leading entry is a specific entry in a matrix. Okay, there can be more than one. There can be numerous leading entries. And what leading entries are just the leftmost non-zero. So they have to be a non-zero number. They can be positive or negative as long as it's not zero. The leftmost non-zero entry in a non-zero row. And a non-zero row, right here, you might be asking yourself, what does that mean? A non-zero row is just any row that has even one entry that isn't zero. So it's very simple, straightforward. When you think about it, it could be something as simple as this. So our top is a non-zero row. Our bottom row is a zero row because there's no non-zero entries. Pretty straightforward stuff. So now that we've gone through that, let's go ahead and introduce our first special form of a matrix. And that's going to be what is called echelon form. So echelon form has three restrictions. In order for a matrix to be an echelon form, the first one is that all non-zero rows, okay, rewrite that, that was really bad. All non-zero rows are above any rows of all zeros. In the next video, what I'm going to go ahead and do is give you a couple examples of these, but for now, don't just worry about thinking and visualizing the best that you can what these all mean. The next is that each leading entry, so like we just learned before, each leading entry of a row is in a column to the right of the leading entry of the row above it. And then finally, all entries in a column below a leading entry are zeros. Okay. So we have different clarifications, so sometimes we need non-zeros, sometimes we need all zeros. Again, don't worry about what this looks like just yet. Just worry that, and don't just think about how you can visualize this right now and do the best that you can. So now let's do the second special form, which is what is called reduced echelon form. Now, reduced echelon form builds on the echelon form that we have, and it takes it a couple steps further. So first, we want to say, it has to be in echelon form at the very least, right? So that's kind of the beginning stages. So you will see all the same characteristics in a reduced echelon form matrix that you see in an echelon form matrix, in addition to the next two things. And the first one of these, the leading entry in each non-zero row is 1. And lastly, each leading 1 is the only non-zero entry in its column. All right, so in the next video, I know that some of this isn't quite as concrete as it should be. In the next video, what I'm going to go ahead and do is kind of show you 2 examples. Right now it's arcane. You don't know what these actually equate to when we look at matrices, but they are actually very readily seeable. When you look at matrices, you'll know exactly what form you're in, and they're really straightforward once you actually see a matrix. But for now, just kind of focus on the definitions, write them down, try to think about them, and in the next video, we'll look at them for the first time.